Welcome to another TSE single slider. This time, clients and servers demystified. If you found yourself unsure about what the terms client and server really mean, you're not alone. Many people struggle to understand the difference between clients and servers, but at the end of this slide, you should have a solid understanding of the difference, and you'll understand why this can be such a confusing topic. Note that for this slide, everything shown on the left is going to be a client, and everything shown on the right is going to be a server. Let's start with some simple definitions. Clients are systems that establish connections, and servers are systems that listen for connections. Note that once a connection is established, traffic can flow in both directions. The direction the data goes, be it one way or both ways, doesn't matter when it comes to defining which is the client and which is the server. What matters is which system established the connection in the first place. What's interesting about these definitions, and one of the things that's so vexing about this topic, is that the labels client and server only technically apply in the context of a connection between two systems. When the connection doesn't exist, there's no such thing as a client and a server. There are just two systems which aren't talking to each other. That makes the client and server labels ephemeral and contextual. Let's look at some examples of clients and servers interacting with each other. First, we have a web browser requesting the Stripe.com homepage. In this example, the web browser is the client establishing the connection, and Stripe plays the role of the server, listening for connections. In our second example, we see Stripe acting as the client when establishing a connection to a merchant server in order to deliver an event to a webhook endpoint. It's important to note that Stripe can be both a server and a client depending on the scenario. Before we look at our next example, I want to talk about something that causes a lot of confusion for some people, which is the fact that computers which mostly or always act as a server are referred to as servers, even though they may sometimes act as clients. You can see this in action in this next example, where a merchant server acts as the client when establishing a connection to Stripe's API in order to create a customer. The fact that something with the name server can in some situations be the client is not intuitive, and it's one of the reasons this topic is sometimes difficult to understand. Okay, now let's look at an example involving three parties. In the first half of this example, we have a web browser establishing a connection to Stripe in order to confirm a payment intent. That makes the web browser the client and Stripe the server. Next, Stripe needs to talk to a financial partner, like a card issuer, to find out if this transaction should be authorized or declined. So Stripe establishes a connection to the financial partner to ask what the outcome should be. In the second half of this example, Stripe is the client and the financial partner is the server. This example shows Stripe acting as both a client and a server in order to facilitate an operation. Our last example, which involves a web developer's laptop, shows how a single system can be both a client and a server by itself without involving any other parties. This laptop has a web browser installed, which acts as a client, but this laptop also has a local web server installed, like Nginx for example. On this laptop, the web developer uses the web server to host their project, and they use the web browser to access it. That makes this laptop both a client and a server, with the client-server relationship established between two different processes running on the same hardware. All of these examples demonstrate the ephemeral nature of the client and server labels, which apply based on the context of a specific connection. That's why we see Stripe on both the client and server sides of the slide depending on the connection being made, and why we see something called a server acting as a client. As long as you keep the following three things in mind, you should be able to determine what's a client and what's a server in any situation. First, clients establish connections. Second, servers listen for connections. And third, some computers are called servers when that's their primary function, but having the name server doesn't stop them from establishing connections as clients. There's some other interesting things to note about clients. First, web browsers and mobile apps typically act only as clients. It's technically possible for a web browser or mobile app to act as a server, but that would be an unusual edge case. The vast majority of the time, web browsers and mobile apps establish connections to servers and thus are considered clients. Second, you may have heard the term client-side languages, which refers to programming languages which are typically or mostly used on clients. HTML, CSS, and JavaScript are client-side languages on the web because the code written in those languages is run in the web browser, on the client side of a client-server interaction. Likewise, in the world of native mobile apps, iOS apps are written in Swift or Objective-C, and Android apps are written in Kotlin or Java, with that code being run on the mobile device itself. Third, Stripe.js, which is written in JavaScript, and Stripe's mobile SDKs, which are written in native mobile languages, are examples of what we call client-side libraries. Moving over to servers, server-side languages are programming languages which typically run on servers. Stripe supports various server-side languages, including PHP, Node.js, Ruby, Python, .NET, Java, and Go. Fun fact, Stripe's server-side libraries are designed to run on servers, which is why we call them server-side libraries, but those libraries actually enable those servers to establish connections as clients to the Stripe API. This is shown in the example where the merchant server is creating a customer. One final note about security. By default, clients and servers should not trust each other. A client and server are usually two separate systems, and both ends are rarely owned or controlled by the same entity. That means, for example, that a web server which sends JavaScript to a web browser to run client-side should not assume that JavaScript will be run without being modified, or it may not run at all. Bad actors can inspect and modify client-side code when attempting to exploit systems, and they also run malicious servers as well. It's important to establish secure connections and confirm trust between clients and servers using certificates, authentication, and other security measures appropriate for the connection being made. To recap, clients establish connections, and servers listen for connections. Some computers are called servers because that's their primary function, but the name server doesn't stop them from establishing connections as clients. Now that you know how clients and servers are defined, you can apply this information to any scenario where two systems are connecting to each other to determine which is the client and which is the server.